Well, hi, good morning. Welcome to my shop here. It's May 18th today. This is day 3 on this radio. Yesterday, I chased out the hum. Very good. Now what? The radio seemed to be working fairly well. FM certainly working well. AM and shortwave sounding kind of weak. So I'm not exactly sure about AM and shortwave. But I think a good way to go from here is to focus on the audio circuits, the later stages of the radio, and go through them, check them for operation. I say them because there's 2 channels of output here. Check them for operation, some voltage tests, look for some bad capacitors, and see if there's anything out of sorts with it. And the way to do that in a complicated receiver like this, obviously, is to start by studying the schematic. So that's what we're going to start out with. Study up on the schematic here. Okay, maybe we'll spend about 5 minutes taking a look at this. Now, the audio circuitry is all the stuff past the detector, and you can tell the detector tube because it has all these little diodes in it here. So this is the detector tube here. So everything past it amounts to all this stuff here. Now it's a stereo unit when you're playing records. Otherwise it's a mono unit, but nevertheless you can draw a line across here. And what's up here is what's down here. This is one channel, this is the other channel. That's easy to see. So why we got 3 tubes here? That's quite a few tubes in an audio circuit. And let's just take a look for the volume control. So the volume control is here. This little bar part right here. So prior to that, I kind of wonder what these 2 tubes are doing here. It could just be a series of amplifiers, audio amplifiers, boosting it enough to operate this. But usually you just have one preamp tube for the output tube. These could be, and I'd have to look at this very carefully, these could be preamp tubes. It's a tube, by the way. It's an ECC 83. It's one tube. See the dashed line here? And the dashed line here? They're trying to say that this is all one. One is 2 tubes under 1 glass bulb. Anyway, this is probably a preamp for the record player, which bodes really well if that's the case. Because if this record player in the console has a preamp, that means it probably has a magnetic sort of cartridge, not a ceramic cartridge. It means a high fidelity, much better fidelity. So, but we don't know for sure what these are. So we look at the output tubes. It's really the right place to start, right here. And well, the first thing we want to figure out is how do they bias these tubes. And it's rather obvious. There's a cathode resistor right here. It says 560 ohms. And then it's bypassed with a large capacitor, 25 microfarad. That's a large capacitor, bypass capacitor here. Good chance this capacitors, there's another one up here, are bad. Good chance this voltage is not 19.5 because the resistors have gone off. And the reason these resistors would tend to go off is these are hard-working resistors. They have all the current that's flowing in the primary of the output transformers going through them. So these guys are working fairly hard. So the bias is arranged through a grid, cathode resistor. The grid, as you can see, is essentially grounded through this fairly large resistor and this very large resistor. Just go down to ground. So by pushing the cathode up positive, they achieve a bias. So the grid appears negative to the cathode, which is the key to biasing the tube. So rather than make the cathode or the grid more negative, they just made the cathode go positive with this resistor. Very common, very common way of doing this. So the audio signal must be coming in on this line and reaching this grid. A couple other things that are available here. Some current flow, which is very hard to make any kind of use of because you have to open wires and insert ammeters to try to read this, but there's lots of voltage information here too. I think that says 250 there. I'd have to get my magnifier out on it to really read it. Maybe it's 260. So these voltages can be checked also to make sure they're correct. But what's controlling this voltage is ultimately the supply voltage and a transformer primary. So I wouldn't expect this voltage to be off. There's no resistor in here. Wait a minute, yes there is. There's one right there. But that's kind of on the output side going to the screen of the tube here. As for the part that's dropping the plate voltage a bit, it's just in here. Okay, so but we can check this stuff. And most importantly, the 19.5. This could be incorrect. Could be too much current or more current than desirable flowing through this tube, causing the tube to run hotter and wear out sooner. Wear out the cathode much sooner, wear the tube out, and you wouldn't know it listening to it. You wouldn't know this is happening. So one way that happens is a bad resistor here. Another way is, and the one I'm most concerned about, is that the grid is being driven positive from a weak capacitor, and that would be this capacitor right here, excuse me. Same one as up here. We need to find this capacitor and change it without too much thought. It's a 0.01 microfarad. It's going to be one of those brownish guys that are generally unreliable. Now we got some more voltage measurements here. Very low, 72 volts. And this tube is getting its signal right from the volume control slider through this capacitor. So this usually doesn't give trouble, but this is another one that could weaken the audio chain if this capacitor is bad. It's not very likely though. The volume control is very complicated. It has three taps on the back of it. These taps have different resistors on them. Right over to the speaker. So some of the output from the output transformer that's driving the speakers, some of it is fed back, finds its way into the bottom of the volume control, and I guess through these tabs a little bit. So one of the things about European radio designers, Germans, they love their tone controls. And so there's a lot of effort put into these radios to affect the tone. And that's why one of the reasons why these radios sound so nice. They do have a nice sound when they're all working right. So the problem here is mainly our ears. And when we listen to something that's quiet, we lose both the bass and the treble. Our hearing focuses on our voice range. Where a person's voice is. So we can still hear that in very, very quiet circumstances. But it also drains out the bass, and I think our treble too gets weak. But the bass in particular gets weak. So at low volume we can't hear the bass that's there. So what a lot of stereos have done is to try to compensate for that, so you have the loud quality sound at low levels. And what they do is they just basically boost the bass to compensate, and that's what this is all about, along with a very large measure of distortion control. So if you take a little bit of the signal right from the speaker circuit and feed it back in 180 degrees out of phase, it becomes a negative feedback. And I won't go into the details of it, but it very cleverly corrects the signal at this point so that what arrives at the speaker is undistorted. It's a very curious thing. It's discovered a long time ago. It's been in radios and all kinds of audio stuff for the longest time. So in any better sounding hi-fi system, I think you're going to have some negative feedback. The drawback is it drops the volume a little bit, but the payoff is really, really good. So So that's what that is. Look at these. Look at these. And there's a switch here. So the engineers just went wild in here. In fact, they tend to go, these European radios, they tend to go just wild with tone control stuff. Remember I showed you there's two knobs that you normally find on a North American radio, a bass and treble, and then a bunch of push buttons just to add some more stuff in there. Okay, so what about biasing of this tube? So you can see the cathode is right to the chassis, so there's no cathode resistor, cathode biasing. Biasing here is achieved with this very large resistor and a self-biasing, although I don't like to use that term too much. Self-biasing takes place here, where this grid will arrive at a negative voltage just through its operation within the tube on its own. It'll pick up charge and become more negative. And the large resistor keeps the charge here. It takes a long time for the charge to bleed down. And then you get a little bit of bias on this tube. Same thing, of course, going on up here. So you could imagine that, here's a 10 megohm resistor. If this is leaky, and maybe this has become a 1 megohm resistor, and then you have a new circuit going down like this. So this can be, I've found a lot of radios where this capacitor is quieting the radio, and with it you got two channels. You want both channels working the same, and they're both quiet or both loud, but not one working and one not. Okay, so we go back further. Now I think we should go to the top of the volume control here and trace back where is the signal coming from. Look at all these little switches in here. What's this guy? Is that the tone control? And not another tone control? I don't know what that is. Through here, and it goes this way through a bunch of switches. Oh my gosh. You're selecting, looks like you're selecting things on the back of the radio. Sockets on the back of the radio. I don't know. Moving up this way. And then we open here. What is that? Open, or is that some kind of switch? Must be a switch. And we're up onto the other one. So maybe through here. So somehow, we have to come from this end. Okay, let's stop here. We'll work our way from this end. The audio here is developed, depends if it's FM or AM. So we'll follow the AM, the AM audio, which should be coming out of the bottom of the transformers. Are very hard to see on this schematic. The two transformers here. And on the secondary side, we should find a wire going to the diode. And we should find a wire carrying on all the way to the audio. I'm not sure what that is. Oh boy, oh boy. So many switches in here. Well, we know somehow. The audio is developed back here. It makes it, I think it makes it to these grids. And so what is this tube? So is it a preamp? Can we figure that out? So we follow the grid. It goes straight to here. The grid get a signal anywhere else, it goes to here. BU1, BU2, BU3. It's got a left and a right. Left and a right. Maybe there's two kinds of plugs on the back of this radio for two kinds of phonos. Don't know, but anyway, you can see that this tube only gets its signal from here, from these plugs on the back. This has to be a preamp for the phono. It doesn't have to be, but in my mind, that's what it's going to be from now on. So the audio's got to be getting from over here into here, probably following. That's the output there. Following somehow. I'm not going to be able to sort it out here. Our objective is to find bad capacitors, wrong voltages, and stuff like that. But got to have some appreciation for what's going on. I think that's enough understanding for now. You don't have to have things 100% understood. Just 99.9. That's all. So let's go in the radio here. We're going to look for these resistors, and look for this capacitor. Where'd it go? This capacitor right here. Gotta find this one and its brother up here. Okay, that's good. Good enough for now. I can only study these for so long before my head is jammed. Okay, let's look at the underside of the radio here. So the two output tubes are here. So what we're looking for on those two output tubes is a fairly high wattage resistor and probably, certainly a electrolytic capacitor 25 microfarad. So they're staring me in the face, that's for sure. So the two resistors are here and the two capacitors are here. These two orange ones here. Proving that out's pretty easy. This just came out of the radio. It came out right down here. So this is the piece that should rotate when you turn the tone control here. There's a little window, it's really hard to see. There's a little window through the front dial and something goes up and down in it. Looks like some notes on a treble clef or something like that. So I think this rubber band is the failed drive mechanism that's supposed to drive this, or somebody put in an elastic band at some point. This one's missing too. This one, hey, over here. This one here. So that's why these things weren't going anywhere. Probably originally they had rubber bands. That seems to make sense to me. Looks wide enough to carry a rubber band there. And over time, rubber bands, they don't last. They don't last. There's another interesting electrolytic capacitor visible here, and that's this guy. So I'm not going to worry about it. I'm just taking note of it. There's something curious about that particular capacitor. So verifying these are what I think they are. First of all, one leg of the resistor should go to ground, and there it is going to a terminal onto the chassis. Capacitor should be doing the same thing. Sure enough, this side of the capacitors goes to a terminal right on the chassis here. Okay. There's little doubt that these are the guys involved. So we can measure these for their resistance and see what my meter says here. Wasn't it 560? Is that what it was supposed to be? 560. These often go high. Okay, RU 560. So from the ground side to this one, 553. And this one, 558. So can't get much closer to 560 than that. These two capacitors, they look to be in great shape. I really don't have any reason to be suspicious of these. In many older radios, you would change these for sure. But here, they just, if I'm going to change that, man, there's another 50 parts to change, and it doesn't make sense to do that. For some reason, Okay, so I think these are good. Now we'll do a voltage measurement. It was supposed to be 19.5 volts at this point and at this point. But we can check for that when we operate the radio later. Now, what was the other thing we wanted to look at? Was there something else we wanted to look at? So we just looked at this capacitor and this resistor. Yes, it was this capacitor. We have to try to find this one. And likewise, this one. Now, maybe if we start with the plate of this tube, this is a ECL 82. I thought this was the ECL 82. And then write the tube number, ECC 83, ECC 80. Where's the, they put this tube number kind of in the middle. Is this, oh, this could all be inside. Well, this, you know what, this could be part of this tube. This could be part of this tube. That's got to be what's happening. That has to be what's happening. So we're looking on the same tube socket then to try to spot. Can anybody read that number? Let me just get out an aid here. I want you to read the number there. So that's a 9, and the number here. Well, it's the same type of tube, so it's the same number, 9. So we go to pin 9 and look for a capacitor attached to pin 9 on that tube. Capacitor attached to pin 9. Let me just put the brakes on here. There we go. Pin 9 on these tubes. Look for the gap. There's the gap. So pin 9 is on one side of the gap. That would be here. Here's a capacitor. Here's a resistor. This looks like orange, orange. This looks like 330. 330. I have to look very carefully. There's lots of wires. Looks like 330, could be 220. Okay, so we're looking at 220. There's a 220K right there. So we found the capacitor. It is this. What we really want to do now is read if there's any positive voltage on the on pin 9. And on this tube, pin 9 is the tube in. Sometimes they put the tube in exactly the same way. Sometimes they don't. Where's the gap? Here's the gap. This is 9 here. How can that be 9? It needs to have this kind of resistor on it. There it is. There. Yeah, pin 9. So we've got pin 9 figured out. So we have a number of tests we can do with the radio upside down like this, looking for critical voltages. Okay, before turning the unit on, these measurements are made to the chassis of the radio, so I'm going to clip my meter negative lead to the chassis, so I don't have to worry about it. We're just running around with the positive. So we will practice now before I turn it on. Practicing. So first we want to look for the 19 volts. We would find it here, and we would find it here. Okay, and then we want to look for, say, the plate voltage. Plate voltage. We should just check it. It should be on. It looks like 6. Pin 6. 50 or something like that. Pin 6, we would count 1, 2, 3, 4, 5, 6. So 6 is here. If we count on here, we go 1, 2, 3, 4, 5, 6. They look totally different. Something wrong with my counting, I think. 1, 2, 3, 4, 5, 6. Over here. 1, 2, 3, 4, 5, 6. Well, it sure looks like different wires on it. 2 yellows. Well, pin number is a pin number, so we'll check with the voltmeter and see what we get. What we expect to get is 0 volts on these grids, but we might read some positive voltage there. Okay, I think we're ready. Break time for me though. Okay, I think we're ready. We want to go on the broadcast band just because that's the broadcast. Volume is where it was. I think it's okay. radio's not plugged in at the back, is it? Yes, it is. Yes, it is. Here we go. Gotta love those dim lights. Okay, of course we can't do these tests with those dim lights in the circuit. Just put them in to make sure everything's okay. Now the high voltage should be on the tube already. I see the magic eye is lit up properly. So I'm going to check the high voltage first off. Pin number 6 to 250. Pin number 6, 250 volts. Take this off ohms because things won't go well if I leave it there. There we go. Pin number 6. 1, 2, 3, 4, 5, 6. Okay, we get 252 there. Pin number 6 on this tube. 1, 2, 3, 4. Whoops, start again. 1, 2, 3, 4, 5, 6. That's why I do this ahead of time. I don't get it. I don't get it. Because I think, well, let's count backwards. Hey, that's a good idea. 9, 8, 7, 6. I arrive at a different pin. How'd that happen? I think this is 6. We have 250 volts there. Very good. Now the next test is the test of the bias. Should be 19.5 volts if I remember right. We'll find the bias right here. So we're getting 21 volts. And if we check the bias on the other tube here, 19.9. So very close. The variation in the bias could be due to variations in the tubes that are plugged in the sockets here. Okay, the next thing we wanted to measure was the grid voltage, and is it going positive? The grid pin is pin number 3. Pin number 3. Okay, I think we should get a 0 here or a very slight positive voltage. 0 would be preferable. Pin number 3. Count 1, 2, 3. This is pin number 3. This might be noisy. We got 5 volts positive there. That doesn't. I thought pin number 3. I thought it did something to do with this and this. Ooh, listen. Yeah, it's hard to listen to with the volume this low. Let's turn it up a bit. So that crashy, staticky sound is not welcome in a radio like this. It's definitely not welcome. It could be from so many different things. I'm just moving some parts here a little bit. Nothing going on there. Could be the push button. These radios have a lot of trouble with dirty switches. These switches get dirty in there. Not sure that's the case here. So, yeah, I'm hearing things I won't bother describing them. Let's get back to what we're doing here. So, maybe I read the pin wrong. Maybe I read the pin wrong. This over here by accident, or here by accident. No, here, 3. Pin 3. I don't know what I did wrong before when I was practicing, but I must have done something wrong. 3, well, there's a 20, there's a 220. Oh, there's a 220 right there. So I tried to prove I was on the right. Wait a minute, there has to be a capacitor on that pin. What am I doing wrong here? So pin 3 has no capacitor. Pin 3, yeah, it's true, right through a resistor, then it gets to the capacitor. 220K. Okay, that's it. I just did something wrong before. 1, 2, 3. So we see, wow, 7. Ooh, careful there, man. Pin 3 over here. 7 is bad. 0 is what we're looking for. 1, 2, 3 onto this pin. No, that can't be right. It's got the cathode on it. I've got the gap right here. What's going on? I keep counting the pins wrong on this side. I am. You know what? I got the gap in the wrong spot. Okay. So just in case you don't know what I'm talking about, in case you're new to all this, I'll grab any little tube. Okay, just in case you don't know about this. So the 2 pins have a gap right there where my finger's pointing. There's basically a pin missing, if you like. And that becomes the key to putting the tube in the right way, and it also becomes the key to counting the pin numbers. So you have to spot the gap. I spotted it wrong. So there'll be 1. That's why I was counting wrong before, too. 1, 2, 3. Okay, it's right here. Ooh. So we're getting almost 9 volts. So that tells me that the blocking capacitor is not doing its job. I think that's the only way to explain that voltage there. You see on the schematic here, if we take this example, we're measuring right here and we're finding a positive voltage when in fact this is grounded through these resistors. This is a large resistor, so it doesn't take much charge to push the pressure up in this wire and get a positive voltage reading on my meter. And where's that pressure going to come from? The high pressure circuit over here. So the plate requires a high voltage. Well, it's only 72. It's not as high as it could be, but it's 72 volts here. So you have this capacitor with 72 volts on one side and hopefully 0 on the other. But we're not measuring 0 here. We're measuring whatever it was, 7 and 9. I don't think there's any other way for this to become positive. So these 2 capacitors need to be found and changed. The rest of the circuit seems just fine. Just turn the power off before I forget. It's live. So we got to hunt down these 2 capacitors. This should be easy to find because we know where the resistor is and all that kind of stuff. Didn't I find one of them already? That would be, again, we're counting 1, 2, 3. Here, off of this terminal, there should be a capacitor here, going somewhere. We should probably find this is probably the same arrangement here. So we come off of pin number 3. 1, 2, 3. This resistor. Go here. Should be a capacitor. Here it is. Going off to this wire. I bet you this wire and this wire, I don't know. I don't want to say. This wire, this green wire, by the way, actually has an insulation failure on it. That's exciting. Let's take a close look at that. Oh my gosh, where's my camera? Oh, it's right over here. Okay, pointer. Not sure about the focus here. Set is off, but it could be charged. A radio like this can hold a charge. So we're looking at this green wire right here. Is that the conductor sticking out? Yeah, it sure looks like it. Well, maybe not. What did I just do? Whatever it was, it just disappeared completely. I don't know, it's a piece of dirt. Oh, there we go. Yeah, it's not a piece of wire, it's a piece of who knows what. It's a piece of who knows what. Okay, well, what I'm going to do is I'm going to change those two capacitors, and then we're going to try this test again. See if we got rid of this positive voltage. Very important for the output tubes. Yeah, I should finish that statement. Very important for the output tubes because the output tubes are looking for 19 volts of bias, and each one's being reduced by 7 or 9 volts because of the positive volt on the grid. So what you're doing, you got the grid and you've got the cathode, and normally you make the grid negative to the cathode, and then you control the current in the tube. But in this case, what they've done is they've made the cathode go positive, right off the screen, go positive. And then you get the difference in voltage and you get the bias. But in this radio, the grids are being pushed positive. So you end up with much less bias. Less negative bias, more current through the tube. More current through the tube, cathode wears out much sooner. These output tubes are expensive. Well, I don't know about the ones in this radio, but normally output tubes are expensive. Why? Because they're rare. Why? Because they burn out. Why? Because of reasons like this. They wear out early. Plus, in any radio, the output tubes are hard working, so they have a lot of current going through them. Cathodes can only produce current for so long before they wear out. That's the story there. Okay, I'll go ahead and do those capacitors. We'll see what happens. Maybe I'm full of crap. Okay, so the capacitors I've changed are not these two, but I've changed two. You can see two orange drop capacitors in here now. Got a little confused. These two capacitors are this one, and the one I've changed is this one. This is the blocker. This one's leaky. It doesn't look like a very good thing either, but I think the positive voltage would come from the leak here, not from the other one. The other one can't leak a positive voltage. Okay, let's find out if I'm telling the truth or not. Just double check here, make sure everything is good. Make sure there's no shorts. Everything is soldered. Good. Okay. Let's try it again. Okay, plug it in. Power up the dim bulbs. So we should find 75 volts on one side of these capacitors, which I didn't do that test last time, and 0 on the other side is what we really should be finding. Okay, full power, full power. And we should be ready to go already. Okay, hoping for a 0 on the meter. Right, this is the plate side. So there's the 70 volts, and here's the other side. 0. I go on this one, say 70 volts, and on the other side, 0. Now if we get right on the grid, the grid was, I don't trust my memory. The problem is I have to remember not to trust my memory. That's the real problem. So we're looking at pin 3. Let's see. Pin 3 tells the truth. Pin 3 was the one with a few volts on it before. So counting pin 3, 1, 2, 3. Is he full of crap? 0. And the other pin 3, count 3. Properly this time. 1, 2, 3. And a little tricky to get on. Here it is here. 1 volt. Okay, that's good. That's a great improvement. Would that change the operation of the radio? Drop the plate current in those two tubes. Drop the overall wattage draw in the radio a little bit. change the tone, change the volume? I'm not sure, to be honest with you. What it would do, though, is the bias, a 19-volt bias, opens a window for a 19-volt signal on the grid. If you put a 50-volt signal on the grid, it's going beyond the range of the bias, and you're going to drive the grid into a positive zone. So as this shrinks, then if you're still in the middle, which is an if, at low volume, you're still within the limits of the tube, but turn it up, and you're going to start hearing distortion because you're going out of the now shrunk bias limits. Shrunk from 19 down to about 10. So now they're back open again. Higher volume, no distortion. That's the scheme, that's the plan. And I think that's it for today. I think that's all I want to do. Oh, I almost forgot. We need to test those two capacitors. So come over here where my tester is. So this tester it's a vintage piece of equipment, and it's designed to test these vintage capacitors given the issues that exist with this old equipment, and that's high voltages. You know, old equipment like this using tubes has high voltages. So one of the issues is what happens when you put high voltage on a capacitor like this? Does it hold its own, or does it leak? So what this device is going to do is going to put 50 volts across this capacitor. For a moment, if you watch the indicator eye here, it's going to snap closed and then it's going to open. How far it opens tells you how much of a leak there is in the capacitor. If there's no leak, the eye is open like you see it now. If there's a leak of significance, the eye will remain closed. And by leak, I really mean electric charge flowing through the capacitor in a way it shouldn't. The capacitors become partly a resistor. That's what's happening. So flip the switch, watch the eye, and we'll see what happens. It came right open. Okay, 150 volt test. Not opening. Brand new capacitor will pop right open at 450 volts. Not this guy. So these were the ones who were responsible for holding back the DC voltage on the plate of the preamp portion of that tube from getting to the grid. They weren't doing the job. We measured it, we found the voltage on the grid. How's it getting there? Charge leaking through these capacitors. There's extremely high resistance in them. It's not low. Okay, 50 volt test on the next capacitor. Here we go. Oh, it likes 50 volts. What about 150? See, now this one's not nearly as bad. 250. I think that might be beyond the rating of the capacitor. Capacitor's rated. No, it's rated for 500 volts. So they put a high rated capacitor in here on the idea that because it's not doing 500 volts worth of duty, but a high one in there because just basically they're stronger, they last longer in important position. Still opening. Well, one was bad, one was not, but changing both of them eliminated or reduced the voltage on the grid. Yeah, the positive voltage leaking onto the grid. There we go. That's the end of that story. I do these. I try to do the work based on indications. Something's indicating something needs to be done, and it's not always the case. And I like to test the parts that are coming out to see what the truth is. I don't want to be Mr. Willy-nilly, just change all those capacitors for nothing. But I'll bet you by the end of the whole process, all these brown guys will be gone. That's my bet. Okay, well, thanks a lot for watching. And like I said earlier, tomorrow we'll just keep moving up. See ya.